student, welcome in our today's session. In last lecture we start our third chapter complex number, and in that lecture we also see the introduction about the complex number, what is mean by imaginary number, what is mean by complex number, why we introduce the complex number I, where imaginary number I is equal to root minus 1 since I square is equal to minus 1, and the imaginary number is always in the form of KR, and complex number which is in the form of a plus br, where a and b belongs to the real number. And next we see the complex conjugate of a complex number. Complex conjugate, first of all, complex number is denoted by z and its conjugate is denoted by z bar. If our complex number is a plus ib, then its complex conjugate is a minus ib. Also we see the properties of complex conjugate of a complex number, that is if we take conjugate of a complex number 2 times, then we will get the complex number itself. Now next one, if z is equal to purely real, that means if our complex number is purely real, then the complex conjugate and its complex are same, and if z is equal to minus times z bar, then the z complex number is purely imaginary complex number. In last time we see what is real part, what is imaginary part. In complex number a plus ib, a is called real part of z and b is called imaginary part of z. Now in this lecture we are going to see our next point, that is algebra of a complex number. First of all, in that we see the equality of complex numbers. Equality of complex number. In paper second, in order pair, we see when two ordered pairs are equal, when the components are same, that is first component is first component and second component is second component, then the two ordered pairs are said to be a equal ordered pair. Here same again, equality of two complex number, where real part of both complex number and imaginary part of both complex number are same, then the complex are said to be equal complex number. Two complex numbers z1 and z2 are said to be equal, if two complex number, that is right here, z1 is equal to a plus ib and z2 is equal to c plus id, are said to be equal if a is equal to c, real parts are same, and b is equal to d. Here real part of z1 is a and here real part of z2 is c. Since if a is equal to c and if b is equal to d, that means real parts and its imaginary parts are same of two complex numbers, then these two complex numbers z and z2 are said to be equal complex number. What is important condition for equality? That is real part of both complex number and imaginary part of the both complex number are same, then we say that the given complex number are equal. Now see our next algebra, that is addition of two complex numbers. Addition of two complex numbers. That means if we have to give a two complex number and then we have to define the addition in between them, since let z1 is equal to a plus ib and z2 is equal to c plus id be two complex numbers, then we have to define addition. Since right here z1 plus z2 is equal to, what is z1? A plus ib plus symbol as it is. So what is z2? That is c plus id. Now we have to take addition. बाबा addition करताना नेहमी real part मध्ये ऍड करायचा आणि imaginary मध्ये ऍड करायचा. So see here, first take real part, that is a plus c plus ib plus id, but here I is common, since take it common, a plus c into I into b plus d, that is z1 plus z2. Now see here, if z1 and Z2 are complex number, then their addition Z1 plus Z2 is also a complex number. म्हणजे जर दोन कॉम्प्लेक्स नंबरची ऍडिशन केली आपण तर ती जी ऍडिशन असते ती स्वतः काय असते, कॉम्प्लेक्स नंबर असते. सी फॉर एक्झाम्पल Z1 is equal to 2 plus 3R and Z2 is equal to 3 plus 5R. I am considering here two complex numbers Z1 and Z2. We have to take addition. Since right Z1 plus Z2 is equal to, what is Z1? 2 plus 3R plus, right, Z2 that is 3 plus 5R. And always remember that for doing addition, take its real part and take its imaginary part. Don't take addition of real and imaginary. So take first 2 and 3. 2 plus 3. You can write directly, that is 5 plus 3R plus 5R. 2 plus 3 it is 5 plus 3R plus 5R, which is 8R. Since Z1 plus Z2 is equal to 5 plus 8R, where A is equal to 5 and B is equal to 8. That means if we take addition of two complex number, which is again in the form of A plus IB, or also write A plus BR. If we take addition of two complex number, then it is again a complex number. Since right here, addition of two complex numbers is again a complex number. Again a complex number. Remember that if we have to take addition, then add real part and add imaginary part separately. Now we see the properties of addition. Properties of addition of complex number. So first property is that Z1 plus Z2 is equal to Z2 plus Z1, which is called as a commutativity. We see this type of property in set also, that is union, properties of union and properties of intersection. Properties of, it is called as a commutativity. It is also called as commutative law. Since if we take addition of Z1 plus Z2, it is same as Z2 plus Z1. So see here, if I am taking Z2 plus Z1, what is Z2? 3 plus 5R. And what is Z1? That is 2 plus 3R. Since see, 3 plus 2, again it is 5, and 5R plus 3R, which is 8R. Since Z1 plus Z2 is also 5 plus 8R, and Z2 plus Z1 is also 5 plus 8R. Since here the first property satisfies the addition, which is called as a commutative law, that is commutativity. Z1 plus Z2 is equal to Z2 plus Z1. Now next, second property, which is called as a associativity. Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3, which is called as a associativity. That means in exam we have to ask the question, if we have given three complex numbers Z1, Z2 and Z3 and verify this property. So first we have to take LHS, then take the solve first bracket, that is Z2 plus Z3, then take addition with Z1. Now consider as a equation 1. Now take RHS, first solve the bracket Z1 plus Z2. Now take the addition with Z3, say equation number 2. If the equation 1 and equation 2 is same, then we can say that from 1 and 2 LHS is equal to RHS. This is our second property, that is called as associativity. Now next one, Z1 plus 0, which is equal to 0 plus Z1, which is Z1. Where Z1 means if we are to take addition of any complex number with 0 complex number, this 0 means right 0 plus 0. I can write this as a 0 plus 0. Then if we take addition of any complex number with the 0 complex number, then the addition is complex number itself. Suppose for example, if we take the complex number 2 plus 3 and the 0, that is 0 plus 0, since the addition is 2 plus 3R, since it is Z1 only. Now next fourth property. रियल पार्ट ऑफ z. z आणि त्याचा कॉन्जुगेट जर दोघांची ऍडिशन घेतली तर काय होतं, z आणि z बार मध्ये काय फरक आहे, त्यांच्या साइन मध्ये चेंज आहे. कुणाच्या, इमॅजिनरी नंबरच्या. z मध्ये प्लस आयबी, z बार मध्ये मायनस आयबी, and if we take addition of this z and z bar, then plus ib and minus ib will get cancelled and we will get only real part. That means 2 times its real part. Addition of complex and its conjugate is 2 times real part of z. And the next one, z1 plus z2 bar is equal to z1 bar plus z2 bar. This is properties of conjugate of a complex number. If we take addition of z1 plus z2 and then take its conjugate, then is equal to z1 conjugate plus z2 conjugate. This is properties of our addition. Now next one, that is subtraction. Subtraction of two complex number. Next one point is there, that is scalar multiplication. Which is a very small point. Scalar multiplication, that if I have a complex number z is equal to a plus ib and k which is belongs to real number, therefore k into z. K means what? Any constant. K is a constant, that is which lies between the set of real number. Then k into z. What is z? That is a plus ib, which is equal to ka plus kb into I. Suppose for example, if z is equal to 5 plus 3i and k is equal to 2, then kz is equal to 2 into 5 plus 3i, that is 2 into 5, 10 plus 2 into 3, that is 6i. म्हणजे जर तुम्हाला एखाद्या स्केलरने कॉम्प्लेक्सला मल्टिप्लाय करायचं असेल तर काय करायचं, दोन्ही पार्टला, रियल आणि इमॅजिनरी दोन्ही पार्ट्सला काय करायचं, त्या स्केलरने आपल्याला मल्टिप्लाय करून घ्यायचं. दिस इज कॉल्ड एज अ स्केलर मल्टिप्लिकेशन. नाउ सी द नेक्स्ट, that is subtraction of two complex number. Subtraction of two complex numbers. Again let us consider two complex numbers, z1 a plus ib and z2 is equal to c plus id. Be two complex numbers, then we have to define subtraction in between z1 and z2. Since right here z1 minus z2 is equal to a plus ib minus, now use bracket for z2 because there is minus sign, and because of minus sign the signs will get changed. So write a plus ib minus what is z2, c plus id, that is a plus ib minus c and plus minus c is equal to minus id. Again take real parts, that is a minus c plus ib minus id. Therefore a minus c plus take I common and write b minus d, z1 minus z2. Since subtraction of two complex number is again a complex number, if z1 and z2 are complex number, then their subtraction is also a complex number, which is a plus I into b, which is again in the form of a plus ib. Suppose for example z1 is equal to 8 minus 4i and z2 is equal to 7 plus 2i. Here I am considering two complex numbers z1 and z2. We have to define subtraction. So write z1 minus z2. What is z1? 8 minus 4i. Write the minus sign. First write z1, then the minus as it is. Again use bracket. z2, that is 7 plus 2i. The 8 minus 4i, because of the minus sign and the plus minus, again it is minus 2i. Now take the real part, that is 8 minus 7. 8 minus 7 minus 4i and here minus 2i. 8 minus 7 which is 1 and here minus 4i minus 2i, that is 6i. Since the subtraction of two complex number we get, that is 1 minus 6i. See here 8 minus 7 1 and minus 4i minus 2i which is minus 6i. If we take subtraction, then see the signs very carefully, because of sign your answer will get wrong. So this is subtraction of two complex number. Now we see the properties of complex number. Which properties of complex number satisfies the subtraction? First property, that is commutative law. Whether the subtraction satisfies the commutative law. Since see, take addition of 2 plus 3, that is 5. Also 3 plus 2 is also 5. If we take the subtraction, 3 plus 3 minus 2, that is 1. But 2 minus 3 is minus 1. Since the subtraction is not commutative. First property of subtraction, that is not commutative. Now see the next. Subtraction of two complex number does not satisfy the commutative law. Or next see multiplication of two complex number. Multiplication of two complex number. Multiplication of two complex number. Now we have to define the product in between two. Let us again consider z1 is equal to a plus ib and z2 is equal to c plus id. Then z1 into z2. Now we have to take the product of z1 and z2. What is z1? A plus ib and z2 c plus id. Now take the product. First a into c plus id plus ib into c plus id. Take the product of two brackets. Then a into c, ac plus a into id, that is ad into I, plus ibc plus I into I square, b into d. I into ib into id. So I into I square into bd. AC plus, take I common from this, then I, AD plus here BC plus. सुरुवातीला आपण पाहिलं होतं का I is equal to काय असतं, रूट मायनस 1 असतं. Therefore I is equal to I is root minus 1 since I square is equal to minus 1. So here instead of I square write minus 1 into BD. Therefore it becomes AC minus 1 into BD, that means it is minus BD plus I into AD plus BC. Here we use I square is equal to minus 1. Value of I square is minus 1 because I is under root minus 1. Therefore the AC minus BD is our real part and the AD plus BC which is our imaginary part, that is A plus B into I. This is the A and this is whole part is B. This is Z1 into Z2. Now again see the example of multiplication of two complex number. Again take two complex numbers. Let Z1 is equal to 4 plus 3i and Z2 is equal to 2 plus 5i. Now we have to take product of Z1 and Z2. Therefore Z1 into Z2 is equal to right Z1 4 plus 3i into 2 plus 5i. Again the product of these two. So 4 into, you can write directly 4 into 2 8 plus next 3i into 2 plus 5i. See 4 into 2 8 plus 4 into 5 20i. 3i into 2. First 3 into 2 6 into I as it is. Plus again 3i 5, 15, and I into I, which is I square. I into I. If we take product, then I into I become I square. Now 8 plus 20I plus 6I, since it is 26I plus 15. We know the value of I square, that is minus 1, right? Here I square is equal to minus 1. Here you use the value of I square, that is minus 1. Therefore it becomes 15 into minus 1, since it is minus 15. Now it becomes a real number. Plus this 26I. Now this 8 minus 15, since which is minus 7 plus 26I. Z1 into Z2. Again, which is a complex number where A is equal to minus 7 and B is equal to 26. So if we take product of two complex number, then which is again a complex number, that is in the form of A plus IB. Now we see the properties of multiplication. Properties of multiplication. So first property is commutativity. Multiplication of two complex numbers. First property, Z1 into Z2 is equal to Z2 into Z2, that is commutativity. That means if we take 2 into 3, that is equal to 6, and 3 into 2, which is also 6. If we take the product of Z1 into Z2, minus 7 plus 28, 6, and if we take the product of Z2 into Z2, Z1, which is also minus 7 plus 26. Now the multiplication is also associative. Z1 into Z2 into Z3 is equal to Z1 into Z2 into Z3, which is called as an associativity. Or also it may be written as an associative law. Next, third one, that is Z1 into 1. Z1 into 1, which is equal to Z1 into 1. जसं ॲडिशन मध्ये 0 ॲड केला कॉम्प्लेक्स मध्ये तर Z1 मिळायचं, कॉम्प्लेक्स मिळायचं, आणि मल्टिप्लिकेशन मध्ये जर 1 ने मल्टिप्लाय केलं तर आपल्याला कोण मिळतो, कॉम्प्लेक्स नंबर मिळतो. 0 is called as an additive inverse and 1 is called as a multiplicative inverse. ॲड केल्यामुळे कॉम्प्लेक्स मिळतो, so it is called as additive inverse. And here 1 is called as a multiplicative inverse. Next one, that is fourth property, Z into Z bar is a real number. कॉम्प्लेक्स नंबर आणि त्याचा कॉन्जुगेट दोघांचा प्रॉडक्ट घेतला तर कोण मिळतो, रियल नंबर मिळतो. कॉम्प्लेक्स आणि कॉन्जुगेट दोघांचा प्रॉडक्ट कॉम्प्लेक्स नंबर नसतो. प्रॉडक्ट ऑफ कॉम्प्लेक्स and its conjugate is a real number. Next, sixth property, that is Z1 into Z2 bar is equal to Z1 bar into Z2 bar. First, if we take the product of Z1 Z2 and then take its conjugate, that is Z bar Z1. If we take the Z1 into Z2 is minus 7, then Z1 into Z2 bar is what, minus 7 minus 26. This is equation number 1. Next, take Z1 bar Z2 bar and then they take the product of their conjugate, then which is also same as the Z1 into Z2 whole bar. So this is the next sixth property of our multiplication of two complex number. Now today I am giving some examples to you to take addition, subtraction, multiplication of these two complex numbers. Find Z1 plus Z2, Z1 minus Z2 and Z1 into Z2 for the following complex numbers. z1 and z2 is equal to 5 plus 2i. Next, z1 is equal to 7 plus 5i, z2 is equal to 1 minus 3i, z1 4 minus 2i, and z2 is equal to 1 minus 8i. 3 plus 5i, and z2 is 5 plus 3i. 1 plus I, and z2 is 1 minus I. This is your homework, today's homework. So we have to take addition of these two complex number, subtraction and product. For these 5 complex number, we have to take addition, subtraction and multiplication of these 5 pairs of complex number. In next lecture, we see our next algebra of complex number, that is division of two complex number. How to take the quotient or division of two complex numbers. So you should try to solve these 5 examples. Define addition, subtraction and multiplication. And if you have any doubt, any problem, then please ask me and write the homework and the notes in your notebook. So thank you.